Okay, so hello everyone, welcome back to another video. And yeah, this is another video in the graph theory plan. I think we have covered flood fill, number of islands, max area of island, number of closed island as well we have covered. So for the day three, the first problem that we have is number of enclaves. So number of enclaves. So enclave is, if you don't know it, it's basically in geographical terms, it means that a territory of a country which is completely surrounded by another country. Okay, that's how the enclaves is enclave mean basically. Okay, so for example, you might be aware that India and Bangladesh had a lot of enclave exclave issue. So yeah, so I'll just read the problem first. Let's get to solving this problem. So it has been asked in Amazon, Google, uh, what else? I think that's those two only. So you are given an M cross N binary matrix, which is called grid, where 0 represents a C cell and 1 represents a land cell, basically like water and land kind of thing, where 1 is representing the land and zeros are the water. A move consists of walking from one land cell to another adjacent four directionally land cell or walking off the boundary of the grid. Okay. Return the number of land cells in grid for which we cannot walk off the boundary of the grid in any number of moves. So what it means is indirectly that uh, for example, if we take this one, for this one we can walk off the boundary, right? Because it's on the boundary. And if there was a one here, then also for this one also we could walk off the boundary because we could move to this one and then walk off the boundary. But since this one is not connected to any other one, so this is the only cell here which for which we can walk off the boundary. Basically, this is the only land cell for which you can walk off the boundary in this case. If you look at these three ones, so it's a land area, okay? In other words, you can call it island as well. But for each of these cells, there is no possible way to get off the boundary because it is completely surrounded by zeros. So in other words, if there is a piece of land that is completely surrounded by zero, because see, all of the cells are no, has not been specified. So yeah, let's take a boundary only. So for example, if a particular island or a piece of land that is completely surrounded by zeros, then we can be sure that there is no way to walk off this one without encountering a zero. Okay, so that's what we need to do. We need to find all such pieces of islands for which are completely surrounded by zeros. Because even if there is one of the land piece of the big island that lies on the boundary, then this whole island, it is possible to walk off the boundary. Now, if I start to draw it, it will be more clear to you. Let me start it. Uh, Let me open the whiteboard first. Okay, so let me use black. Yeah, it's very. Let me do this thing. Okay. Mm, 0, 0, 0. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, and 0, 0, 0, 0. Okay, so this is how the input grid looks like. Number of enclaves. So yeah, if I use another color, not able to see the cursor, that is issue here. Yeah. So if we put aside the enclave exclave terminology, we can find that we just need to find the piece of islands which are not connected to the boundary. Okay, piece of lands completely surround. We need to find pieces of land completely surrounded by water. In this case, it is called sea, uh, with no land cell on the boundary. What I mean by that is, if this was one, then this whole land mass will not be counted as an enclave because it is possible in that case to walk from this one off the boundary. Okay, we can move like this and off the boundary we go. Similarly for this one, if this was one. Since it is not one, it is completely surrounded by zeros. Okay, if we take the second example, so see the answer here is zero because it is possible from all these ones to walk off the boundary. We just need to move up, up, and just go from this cell to the boundary. So all ones are either on the boundary or can reach the boundary. So if I were to rephrase it, we need to find the ones from which we can neither walk off the boundary nor they lie on boundary. So these two should be able to explain you what we need to do exactly. Now again we'll start with the same approach. So let me write approach here. We'll start iterating through the grid, okay? And processing according to the logic that we have, okay? And to create these islands, we'll just do DFS, okay? To bunch them all together and visit them together. To visit all the ones and zeros together, in this case, we need to visit all the ones that are connected four directionally together. So we'll use DFS technique for this. So in this case, if you see, we'll start from 0, comma 0. If one, visit and perform DFS on it. If zero, skip it. We shall do this for all cells, for all unvisited cells. Here we need to keep in mind that whenever we are performing DFS, we need a certain variable, a Boolean variable you can take, a certain flag basically, that will tell us whether this island has a 1 on the boundary or not. So we need a flag to determine whether a particular island has a 1 on the boundary or not. That's the only check that we need to keep track for every island that we perform DFS on. Okay. Now, if I were to write the code for this one, you can just I'll just move this aside. Have a look at the function that has been given to us. So it says public int number of enclaves integer. This is grid. So just like previous graph theory problem that we have done, just store the m and n values, which is row and column values. Uh, right. Similarly, we will need one variable that will store the final answer, initialize it to 0, and we will need one flag variable. So again, we can maintain a Boolean visited array, which we will do. Okay. For keeping track of whatever cells that we have visited. Okay. And we need a flag variable as well. So why this is an array of size 1? Because I want to pass it by reference. Okay. Now yeah, just write the two for loops for visiting. Now the if condition will come. When to actually perform DFS? Okay. So we know that we only perform DFS for the cells which have not been visited and which are not 0. Okay. If you go back to here, so if it is 0, we will skip it. If it is 1, we visit it and perform DFS on it, provided it is unvisited. Okay. So that's the condition that I will write here. If it has not been visited and if it is not 0, so if grade ij is not equal to 0, then only we will perform DFS. So let's call our function DFS, pass on the grid, I row and column values, boolean visited, and the flag variable. But our flag variable initially will be true, okay? And if it becomes false, so we will change it to false whenever we encounter a one that is on the boundary. Initially true, but we will change it to false for, sorry, if we encounter a one that is on the boundary while performing a DFS for an island. One thing that we need to make sure is the flag 0 value is initially true. Okay, flag value is true. If even after performing DFS, the flag value is true, okay, we need one count variable as well because we need to count. If you go to the problem statement, you have to return the number of ones as an answer, which are in fact enclave, which are indeed an island that are completely surrounded by zeros. So we need one more count variable, count, okay, and we will pass, sorry, count here, okay. I think that's all, okay, for this function. Now we just need to write the code for DFS. How we will make sure that the flag turns to uh, flag value becomes false if we encounter a 1 on the boundary. So it is very simple. If you see DFS, provide the grid. It is an integer 2D, um, and we provide row value, column value, boolean flag, and count. Okay. Now if r is less than, so this is the boundary condition. Okay. If while performing DFS, if there is a situation that arises where a particular a DFS iteration tries to go beyond the boundary, what that means is that DFS must have been called from a cell which was on the boundary. What it means is, if we have, let's say, this grade, this condition can only arise if there is a 1 on the boundary. Think about it and let me know if I'm doing it correctly. M and N values provide accordingly. I miswrote it, but you just need to provide grid dot length and grid 0 dot length. Okay. If this is the case, what we need to do is we need to just make flag as false. That's all, and return. This is the only modification over the previous I'll graph and island related videos that we have done. Okay. Also, if if it has been visited, then also we don't perform DFS on its neighbors. Now, if a cell is not been visited, we visit it. Okay, visit that cell, increment the count, and perform DFS on its four neighbors, north, west, east, south, all of them. Just repeat it 4 times with these values: r minus 1 comma c, r comma c plus 1, r comma c minus 1. Okay, and that's all. Okay, now let's write the code on the editor to see if our logic is correct or not. Yes, okay. First thing first, just store the m and n values. This step is optional. You can use these grid.length properties as well to directly use the m and n values. But for understanding purpose, I like to do it like this. Also, we maintain a num enclaves variable which is set to 0. We maintain a visited array. Okay. We also maintain a flag variable, and we also maintain a count variable. So flag and count I want to pass by reference, and I don't want their values to change in a particular DFS cycle. Okay. So that's why in a certain DFS recursion, I don't want these values to change. That's why this is an array of size 1. If it has not been visited, when we should perform the DFS? When it has not been visited, and if it is not 0, then only we should perform the DFS. One more thing, we need to set the flag to true, and it will become false when there is certain island that we find by performing this DFS which has a 1 on the boundary. Then only its value will become false, and that will allow us to segregate those kind of land cells from the cells which are on the boundary. Okay, that is one of the ways to do this problem. Another ways is you can maybe just perform DFS on all the ones that are on the boundary and maintain a count of total number of ones overall and total number of ones which are part of an island that has a one on the boundary, and just subtract the two information. You will get the number of ones that are inland, basically, that are surrounded by zeros. That is also another way, but I like to do it this way because it's in alignment with the kind of problems that I have done. Okay, the way that we have solved the previous problems also. So yeah, flag we have set the true and DFS. Okay, and also make sure you restore the count after each island. Okay, but before that, we need to do this. So if flag is still true, this variable should be incremented with the number of ones. Then restore the number of ones that are present in the island, because we need to restore the number of ones for the next iteration, for the next island that we will find. Okay, I think that was enough. Yeah, that's all. Now we just need to, okay, we need to return here number of enclaves. That is the final answer. Why this? Sorry, this should be grid. Yeah, okay. Again, we just need to write DFS, which is provide the grid, provide row, provide column, provide the visited array, provide the flag, and provide the count. If it is out of bounds, then we know for sure that this particular island has a one that is on the boundary. That is only this one can push this DFS recursion to go out of bounds, okay? Because it will try to visit neighbors of this one, okay? That's the thing. And zero also we are not visiting. So here, I think I missed one thing, that if it is zero also, then we should also return, okay? That's the condition that will come in this line as well. That we will write it. But for now, if this DFS recursion enters this if statement, it will only happen if there is a 1 on the boundary. That is very important to understand. Only a 1 on the boundary can cause the recursion to go out of bounds. Otherwise, it will end. It will find a 0 and it will end there. So now, yeah, the flag value should be changed to false in this case, if that happens. Also, we shouldn't do DFS for a cell which has already been visited, or if it is 0, just return. If all that is not met, and if it is a genuine one which has not been visited, we should visit it first of all. And we should count it as well. We should do a count. Uh, Count 0 plus plus. Yes. So one scenario that you might be thinking of, okay, what if we are trying to find an island? We are in this situation, okay? If this the count will return 4. That's for sure. It will return 4. But the flag value will also be false in this case. So this flag value will help us decide whether we should add that count to a final answer or not. Only for the ones that are inland, that are part of an island that is totally surrounded by 0, we will add that count value. Otherwise, we will not add it and we'll just reset it to 0. Okay, so now this is done. We just need to call DFS on its 4 neighbors. Okay, uh, shall we try to run it? Looks good to me. Let's see. Some error will pop up. No, it is working fine. It is 0 and here it is 3. Let's submit it. Okay, so it's accepted, but the runtime is quite a bit more. Okay, it's taking 20 milliseconds. Memory is also not good. Let's try to do something about it. Memory, obviously, we can improve it using the previous methods that we discussed in the previous problem, which are flood fail and number of islands and all those. What we'll do is we'll just get rid of visited altogether and we will modify the cell value because modification is allowed. Nowhere it is said that we can't modify a certain value in the grid. So what we will do is we will use a certain number to mark it as visited. So I'll use 2 here. Okay. Mm, yes. Once you have visited the cell, it is no longer useful for you, so you can do anything you want with it. In this case, I am modifying its value to 2. Okay, so space complexity has improved at least. It was earlier O of Mn. It is now constant space-time. Constant space complexity because we are not using any such variable that grows with the size of the grid. So if we submit it, let's see what improvement that we have done. It is instead taking a lot more time. Uh, I told you, right? These numbers are not really believable. And yeah, one more thing. My internet has got disconnected for some reason. Let me try to reconnect it. That could be the reason why the runtimes are being shown as very poor. See, now it has improved. So it's dependent on a lot of things. Uh, yeah. So if we write the time and space complexity for this approach, O of mn, because you will visit every cell at most once. Okay. Space complexity will be O of 1, because the only space complexity or only variable that we were using that was growing with the size of the grid was the visited array, which we have gotten rid of by using this trick basically. But runtime is not great, to be honest. So I'm just thinking of what else that we can do. Return the number of land cells in grid for which we cannot walk off the boundary in any number of moves. Can we try another approach like that I was talking about, where we perform the DFS for the ones on the boundary, get that count, and subtract it from the number of ones present in the grid? I think this approach is already pretty optimized, but let's try that also, which I'm talking about. So in that approach, the flag will be gone, not needed. What else? This, yeah. In that approach, we need to find the number of ones first. And count also we will need, I think. Flag we won't need. We won't need this thing. Now, just total ones plus plus. I think this should take a lot more time because it will involve two iteration, because first we need to calculate the number of ones, okay, in total, and yeah, which we are doing right now. And in the second iteration, we will perform DFS on only the boundary elements. So from, I think this approach is not optimal in my case. I mean, it's almost that time complexity where it's almost equal to O of Mn, but this is a little more complex, I think. So what this says is we should only perform DFS for the boundary elements. Okay. So if I is equal to 0 or j is equal to 0 or I is equal to m minus 1 or j is equal to m minus 1, sorry, then only it should perform DFS grid C count. Okay, there should be one more condition actually. This condition should be met and a particular ij shouldn't be visited. Now this condition can come up. Okay, so after this we just need to increment this invalid ones. Okay, we are resetting for every DFS call, we are resetting the count as well. There is some bracket issue that is happening. Okay, it should be ij. Okay, flag also we need to remove. So I'm just trying to debug it. Okay, uh, see if this approach works. So it is accepted. Okay, it's working, and yeah, now the times are much more acceptable. Okay, so what we have done in this approach is first of all calculate the total number of ones present in the grid. In this case, it will be 4. So 4 will be stored in total ones variable. In next iteration, for every one that I encounter on the boundary, I will perform a DFS so that I can store the count of invalid ones. Invalid ones means ones which are which will not be counted in the final answer. That's why we are subtracting it from total ones. These are useless ones for us because they lie on the boundary and they will allow you to walk off the boundary. But we want to find the land cells for which we cannot walk off the boundary. Okay. So in this case, total ones is 4, invalid ones is 4. So that's why the answer is 0. In this case, total ones is 4, invalid ones is 1. So answer is 4 minus 1, 3. So yeah, that's all I had to discuss. So this is again, this is yeah, no variable that grows with the grid. So O of 1 time complexity and yeah, sorry, space complexity and time complexity is also O of mn because in first iteration you are just uh, visiting all the grid, okay, O of mn plus, so it's kind of like O of mn plus, and again you visit, okay, and at most you will visit all the nodes, so it's comes down to O of mn only. Because if you have visited these four once, you won't visit it again, right? One more thing that I was thinking of applying here was this is currently performing DFS for zeros as well. I feel so. I think so, yeah. It is performing for zero also. So we need to make sure that we don't do it for zeros. Yes. For zeros, there is no need to do the DFS, right? Yeah, again, it's almost the same thing. So yeah, that is two approaches to solve this problem. Let's look at the hint as well. Can you model this problem with a graph problem create and okay. It's kind of hints are not quite useful in my opinion in this case. But yeah, that's the approach that I want to discuss. Hopefully this video was useful for you guys. Uh, yeah, let's meet in some other video as well. Graph theory, there are lots of videos to be covered. So we'll be covering them one by one. Thank you.